So if we were in class right now, I would start off by asking you, what is the coefficient on x? Okay, and many people would say that the coefficient on x is 5, right? That's the number in front of x. If I told you you were wrong, that 5 is not the coefficient, right? That would probably be enough information for you to recognize that actually x is being multiplied by 5/7. Okay, so these two expressions mean exactly the same thing. So what we're going to be doing in a lot of these exercises is ripping our coefficient and our variable apart. Okay, or coefficient, or we could call this the constant, because we had that constant multiple rule where we were taking derivatives, where we can move our constant out of the way, do our calculus, and come back and multiply the constant in at the end. So for example, if I were taking the derivative of this expression, right, what is the derivative here, right? We know that the derivative of x is just 1. So the derivative of this expression would just be 5/7. So let's just look at a couple things on this homework exercise together. So this is what you're doing for homework. And let me just start down here with number 8. We'll do that one together. First of all, we should all know that radical x is x to the 1/2 power. Okay, then we want to think about, is the 3 also under the radical? And obviously it's not. Okay, so the 3 is not being raised to the 1/2 power. So again, we want to think of this as two separate things. We have our constant, right, which is actually our 1/3, right, being multiplied by 1 over radical x. Okay, so it's only the radical x, right, where we would have x to the 1/2 in the denominator, and then of course we bring that upstairs as x to the negative 1/2. If I asked you to take the derivative of this, because this whole assignment is just working with exponents and getting you used to putting these expressions into the right form. But if I asked you to take the derivative of this, okay, we would rewrite it to this form here in A, all right, and then I would multiply. So some of you might find you need to go back and do that fraction remediation assignment from the beginning of the semester, right? I would multiply the negative 1/2 by the 1/3 that's already in there. You might wonder, why did I just put the negative out here, right? Negatives go in front. Okay, so that's why I put it in front of the 1/3 instead of the 1/2. Then I decrease the power by 1. So let's see, that would be subtracting 2 over 2 to get me negative 3 over 2. Okay, and then we do what I call the cleanup step. Okay, so this was the step where we rewrote. Okay, and so then this is the cleanup step where we combine our like terms and we decide what's upstairs and what's downstairs, right? So I have a 1 upstairs, a 6 downstairs, and then I have negative exponents. So we take our negative exponents and we throw them in the basement, right? And so that becomes x to the 2/3 in the denominator. Okay, if you wrote it like this, that's okay, right? I'd rather see it though as one single expression. Okay, so this is my preferred answer. So let's look at one more of these. So in this whole section here, I'm trying to get you to put it in the form that you need to have it in order to be able to take the derivative and apply the power rule. So let's look at this one together, number 11. All right, and then I'll have you finish this for your participation. So in number 11, again, take the constant, the coefficient, pull that apart. Okay, so we're going to rip the expression apart. Okay, so that would be 2/5. And then over here, I hope we know that the cubed root of x is actually x to the 1/3. right? So we've got x to the 1/3 in the basement, right? So bring it upstairs and it becomes x to the negative 1/3. And so for part of your participation, you will find the derivative. So I'm going to put the ddx in front of this. Find the derivative of this function of x. And then there's one other question with the participation, and that's all you have to do to prove that you've watched the video. So thanks for watching.